Afternoon. Welcome to Millionlights. My name is Pratik Shah. I'm an assistant professor in Dr. D.Y. Patil School of Engineering. And today we'll have a live lecture on Arduino and applications of embedded systems. Before starting with the lecture, what I'll do is we'll just briefly discuss about the course that we already have on Millionlights. We have designed a course called as Arduino based embedded systems and robotics, in which we are designing lot of different embedded systems. We are connecting lot of sensors, and we are also having output devices. We are connecting them with Arduino. We are writing the program, and we are doing lot of interesting and innovative projects in that course. To tell you about that course, we have total 19 episodes. Out of first episode is the introduction to the course, in which we discuss about the content of the course and applications of that course and where it can be used in industry and all that things. And from second episode till the 19th episode, we are doing all the hands-on experiment. Means what? We are first in the second episode we are discussing about Arduino, what is its hardware structure, what Arduino is exactly, and how to connect devices to it. Along with that, we are also discussing about few of the software of Arduino, how to use that software, from where we can download the software, and these things. And from next fourth episode onwards, we are starting with practical experiments. We have discussed LEDs, then we are talking about passive infrared sensor, ultrasonic pressure sensor, LDR, that is light intensity register, that is used to measure ambient light. So we are dealing with lot of input sensors. Along with that, we are also dealing with the output devices which are controlled by our Arduino, such as LCD, and then we have motors. We are discussing servo motor, stepper motor, and DC motor. Then along with that, we discuss 7-segment display and all this kind of stuff. Now the main of this workshop or this course was to people how easy it is to design embedded system with Arduino. So it's a very interesting course, and today we'll have a live lecture in which we'll be discussing about embedded systems and how Arduino can be used in that embedded system. So embedded system. Now embedded system is a very vast topic, and it has got lot of contents in it. So discuss embedded system in one difficult task. So but I have tried to simplify it, and we'll see how it plays out. The first thing that I would like to discuss is the definition of embedded systems. This definition that I have is a very simple kind of definition. If you refer many books, there are many books on embedded systems, many websites which have got lot of detailed definitions, and discussing that at this point won't quite a good idea. So I have taken a very, that is, it says embedded systems are the systems designed for a specific task. That means they are the systems that are used for only what. I'll give you an example of embedded system. We'll discuss many examples so that the concept of embedded system is very clear. The first example that I can take is a camera. The camera is an embedded system because the embedded system is designed to do just one task, and the work of camera is to just take pictures and video. The video is nothing but 30 images per second, so it is one second. So the is to take pictures. So an embedded system that is doing only one task, done. Then the next thing is MP3 players. MP3 player is also an embedded system, and that is used to listen to the music or the audio or the songs. So in that way, if we take one more example of embedded system, is a TV. So TV is an embedded system as it is used to watch channels and movies and all kind of things. Radio is an embedded system. If you take a look around yourself, you will see that you are surrounded by numerous embedded systems. For example, if you take a look, then you will have an AC in the room. That is again an example of embedded system. And washing machine, fridge, refrigerator, everything like this oven and all, everything is an embedded system. These are the standard embedded systems. Along with that, you can also have customized embedded system that can be made by you for a specific application and task that you want to design. Suppose you want to increase the security of your home, so that at night if somebody is trespassing or somebody is coming without a permission, you want to detect that, and you want to have an alarm. So you can make an embedded system like that. You can use an PIR sensor, that is passive infrared sensor, that can detect the presence of any human. Then that detection of human, that can be given as an input to the CPU or controller or processor, and after that you can have an output. In output, what is the action that you want to take? If somebody is coming at night, then there should be an alarm. So you can connect the buzzer as an output device to the processor, controller, or whatever you have as a processing unit, and the input will be PIR sensor. And code will be very simple. Now we'll not talk about the code, we'll talk about the algorithm. Algorithm will be to detect the presence of any human. How will that be done? That will be done by by seeing what the input is. So we'll take input, we'll check the status of it. If somebody is coming, then we'll detect it and we'll give an output to the buzzer. So this is one system. Along in this way, we can have many customized embedded system that we can use for our daily purpose kind of thing. So if you want to make your car a smart car, then you can also design an embedded system. You can have sensors that can be measuring the distance, and you can have lot of other things, such as if you're not putting seat belt, then the car should not the ignition should not be on. So some projects like that can also be done. Now we have discussed what is embedded system. Okay, fine. But the crux of it, or what we want to discuss in this topic, is how can we use Arduino in embedded system, and why to use Arduino in the embedded system. Now actually I had told you that we have something, that is processor or controller, that is taking the decision. Now if I have to write the code for it, then that becomes very difficult, because if suppose you have an laptop or PC, it has got Intel i3 processor, i5 processor, or i7 processor. So using an i3, i5, i7 processor and writing a code for it is a very difficult task. So we don't go for that higher kind of processor. We'll use simple processors or controllers like 8051 PIC or ARM. So taking that processor or controller, writing a code for it, and to use that processor, we need to provide a lot of hardware devices are to be connected with it. We need to uh, give it supply and lot of things. So for that, uh, it is a very difficult task, because it requires a lot of experience in that field. You need to learn the block diagram of that, and you need to learn lot of things for using that. But if you are designing an embedded system using Arduino, it is just a matter of 2 hours. If you give 2 hours time, you can understand how to use Arduino, how to write the code for it, and you can design an embedded system with it. How is that possible? Because the programming of embedded system is very simple. The main problem with all these controllers and processors is that the programming is difficult and they cannot be used standalone. We need to add crystal oscillator and few resistors and few circuitries required for its operation. But with Arduino, that is not the case. We just need to buy the board. We can get the board, and the coding of it is very simple. We'll write a very simple code for it, and after having that simple code, we can uh, we can make sure that this embedded system is working properly. Now in just to tell you about, as I was talking that code is very easy, then I'll just tell you two instructions which will be very, with the help of that you can understand how easy it is to code Arduino. Now if you want to accept any digital input, you will have to just write an instruction called as digital read. So digital read is an instruction that will read the input. So if it is either 5 volts or 0 volts, that is logic high or logic low, it can detect. And if you want to produce the output, say you want to switch on anything or switch off anything, then you can use digital write, then high or low. That's it. So these two instructions are very sufficient to take an input and produce an output. This was for digital. Similarly, if you want to accept an analog input, then we have an instruction called as analog read. So in this way, the programming part is quite simple. Since the programming is simple, designing an embedded system is not at all a difficult thing. Now, along with that, the hardware structure of Arduino is also quite quite simple. Now we'll discuss about that thing, but before that, we'll see first what an Arduino is. Arduino is an open source electronics prototyping platform based on flexible, easy to use hardware and software. So it is an open source electronic prototyping platform. Means what? It is open source, therefore all the implementation details of Arduino are available on the net. So you can even make an Arduino by yourself, and it is easy to use hardware because we'll see later on that we have got very simple hardware structure of it. Its software is also very simple. Now software is very simple because we have only one software, that is C++ based, and that software is capable, that is an integrated development environment where we write the code, we check whether the code is okay, and we can compile the code in the same software, and with the same software we can dump or burn the code from your PC onto the Arduino. So that is the thing regarding Arduino. So now we know what is Arduino, and these are different types of Arduino that we have. Arduino is a community that has produced lot of different boards like Arduino Uno, Arduino Mega, Lilypad, and Nano, etc., etc. So now we'll discuss about the Arduino components. As I said earlier, the programming we have discussed is quite simple, done, but hardware is also one thing that we need to take care of. So if you see here, in this hardware structure or this board, this is the board of Arduino. We are talking about Arduino Uno now. In this way, we have a lot of 19 plus boards of Arduino are available, and the beauty of Arduino is that same programming can be used for all the different boards. So if you learn Arduino Uno and the programming of it, same programming can be used for all the other boards as well, like Lilypad, Mega, Nano, etc., etc. Now here, if I use this board, and if you want to learn this board, we'll just discuss four parts in this board, four components we'll be discussing. After that, you are ready to go, you are ready to use this, and you can go on and start with your first experiment. Now in this board, if I have to talk, then first I'll talk about the power. So the power, this thing. So for all the electronic components to work, we require power. Without power, nothing will work. For your laptop, PCs, projectors, camera, everywhere, even mobile, we require power. Without power, they cannot operate. So either you provide it by mains or you provide it by battery. Without power, they cannot work. So similarly, for Arduino board also, you require a power. So it works on 5 volts. So you can connect an adapter of 9 volts plus, then that is sufficient, and that will be enough to power this Arduino board.
So thank you so much, sir, for giving us insights on Arduino. And talking about Millionlights, Millionlights is an online content provider, an educational content provider. So in India in 21st century, everyone needs good skills and to make a good career. So if we see in two-tier cities like Nasik and Aurangabad, and if we compare it to metro cities like Mumbai and Pune, the quality of education is not that good. So we are here to help you, and we Millionlights, we have tie-ups with best institutes like Microsoft. We have tie-up with IIT Mumbai, Sailor organization as well, and we have mobile application, we have our OTT medium as well, and we have TV channel as well, which helps you in preparing for future and career. So we'll now take some of the questions from our users and from our viewers. So we have a question from Ms. Nupur. So the question is, can we have more than one inputs for the embedded system?
Yeah, of course, we can have more than one inputs. Actually, I was talking about simple embedded system, hence I took a case where we were discussing only one input and some kind of output. We can also have many or multiple inputs. For example, if you want to automate the room, if you want to control the AC and or say fan and light. So what do you want? You want a temperature sensor and a light, or a temperature sensor and a light intensity measuring sensor. So we have two inputs at a time, and but we need to write the code accordingly, so that we are measuring both, we have a threshold value, we are comparing it, and then two separate outputs are controlled and monitored. So
Okay.
yes, of course we can.
And one more question we have, that what are the output devices that we can connect to these embedded systems?
Okay, output devices actually we can connect. If you want as an indicator, then you can connect LEDs or buzzers. If you want to display text, then you can use LCD. If you want to display digits, then you can use 7-segment displays. If you want to have any mechanical motion, so we can connect motors to it. If we are able to rotate a motor, then we can have a gear assembly and mechanical setup. With the help of that, we can do anything, open a door, or we can do any mechanical action. So we can connect, the output devices can be motors like DC motors, which are used to either turn clockwise or anti-clockwise. Similarly, we have stepper motor. Stepper motor is for precision of rotation, like 90 degrees, 30 degrees, 40 degrees. If you want to rotate for a particular degree, then we have a stepper motor. Then servo motors are there. So a lot of devices can be connected, and these are kind of things. One more important thing that I forgot was relays. So we can use relay, and relay is one device. If you switch on or off the relay, a relay is an electromechanical switch. If you can switch on a relay, you can switch on AC, fridge, TV, any heavy duty electronic device. Because relay is switched on, then it can be switched. It can be connected to mains, and mains can be connected to AC, fridge, anything. So these are kind of electronic devices, output devices.
Okay. So we have one more question, that can we use Raspberry Pi instead of Arduino?
Yeah, we can use Raspberry Pi also, not an issue. The thing is, why we are talking about Arduino in this course, because this is a very simple board. Because we can also use Intel Galileo, Raspberry Pi, and lot of different things. Esquilo is also a board. A lot of boards that are available, but the thing is, programming of Arduino is quite simple. Hardware is also simple. Raspberry Pi also has got a good hardware structure, but the programming of Raspberry Pi is difficult kind of. You need to understand Linux and how Linux is used, and then the installation of Raspbian operating system on it is quite difficult. So you need to be quite evolved if you want to use Raspberry Pi. Arduino is for beginners, and it is for and the community of Arduino is very huge. So if you have any troubles, you can put it on the web and you will get lot of answers for it.
Mm-hmm. Okay, so we have one more question. It seems that he saw the video on interfacing a LCD on Arduino.
Okay.
But can we connect to the larger LCDs? That's what he's asking.
Yeah, we can connect it to the larger LCDs as well. Just we need to understand now, what we have taken in the course was 16x2 LCD, in which we had 16 columns and 2 rows. So if we are talking about GLCD and various different LCDs, we can connect it, and we can program it, and we can operate it, not an issue. Just the thing is, we need to find out the instructions, what are there, and we need to see how the hardware structure is, what all pins are there, how they need to be connected to Arduino, and we have to check whether we have got libraries for them. So as in LCD we had got LCD header file, and we had a library. So in that way, do we have that? That is one thing that we need to check, and we can definitely use it, not an issue.
Okay. So we'll take up one more question.
Yep.
So what is the selection criteria for various Arduino boards?
Yeah, as I discussed earlier, we have got 19 plus boards. Now the selection criteria would be number of pins that you want. Like in Arduino Uno, we have got 20 pins, 14 digital and 6 analog. But if I have, like the previous one, they were asking about other LCDs which are having a lot of different, they might have many pins. So for that purpose, we need to have more than 20 pins. For example, say if you want to connect more sensors, then that is not possible with Arduino Uno. Then you can definitely go for Mega, because Mega has got lot of digital pins and lot of analog pins. So it has got almost, I guess, 56 plus 50 plus, I can say, to be for sure side, 50 plus pins are there. So one selection criteria would be the input and output GPIOs. So depending upon that, you can go for mega, nano, and etc. etc. That is one selection criteria. The second one would be the speed. So like mega Arduino Uno works on 16 megahertz clock. If you want higher speed, then you can go for the other boards that are using ARM processor and all. One more criteria would be number of serial ports. Like Uno has got one serial receiver transmitter. If you want more than that, if you want 2 3, because see, for Uno you can only connect it with PC or some other device for serial communication, like GSM and all. If I want to connect GSM, if I want to connect PC, or if I want to connect more than 2 3 serial communicating devices, then that cannot be used. Uno cannot be used. So I need to go for mega or higher version. So one was GPIO, second one was speed, third one was the serial communication capabilities. Similarly, we can talk about this and this number of what PWMs. So these few are the selection criteria based on that, and few of the Arduinos are having inbuilt capability of Wi-Fi and all. So they are coming up with various different things. So depending upon need, these are the selection criteria.
So apart from the Arduino, we have lot of courses on our website, and we have newly launched courses like HTML5, CSS3 for beginners that are by Microsoft, and we have a new course JavaScript that is by Arduino by Millionlights itself. And we have one more question. So do we have to write the code for the devices, or can we get it online?
Okay, so the thing is, you definitely get the codes for all these things online. As I said, we have got very huge community which is working on Arduino, so you have got lot of codes available on the web. But the thing is, you need to customize it, because that person might have connected a sensor at a particular port and then he's programming for it, and if you connect it to another port, then it will not work. So you can use that code, like if you're talking about, you can connect a Bluetooth module, you can connect an Zigbee module and all. But all these things, one thing we need to make sure that we need to first understand the code. We can use that code, but we need to check whether your connections are according to that code. So along with the code, you also get the mapping of input, outputs, and the pins. So you should see that also. You can definitely use that. And if you are connecting multiple devices, then you need to mix 2 3 codes and you can work on it.
Okay. And I wanted to ask one more thing, that as Adina is a very advanced course, so is it there in syllabus of any university still or not?
Yeah, now actually from this year onwards, University of Pune is having Arduino. We are having a subject in mechanical department. Actually, Arduino is from electronics thing, and it is for electronics people. People feel like that, but if you see in second year itself of mechanical engineering, University of Pune has got this thing. So there are 3 units on Arduino, its connection and its programming and all. So our course covers all these things. So if you take our course, you are done with 3 units and practicals of this Arduino. So in University of Pune we have similarly lot of autonomous colleges and private universities. They are also taking it and they are working on it.
Okay. So it is there in Pune University.
Yeah, it is there in Pune University.
Alright, so we have a lot of questions, and if any of our viewers have any questions, they can ask us. Mr. Pratik Shah will answer their questions as well. So we have one more question. What is the resolution of ADC in Arduino Uno?
Yeah, resolution of ADC in Arduino Uno is of 10 bits. So we have got 10-bit resolution. That means number of levels that we have is 2 raised to power 10. That means 1024, 1024 levels we have. So if we start counting, then we will start from 0 to 1023. So this is the resolution, and with the help of that, any analog input can be converted into 10-bit digital output. So that is the resolution.
Okay. And we have a question from Ms. Jesleen, that what impact does resolution of ADC have on process of analog to digital conversion?
Yeah, now regarding this, the ADC, as for that I need to tell you what is analog and digital, because we have not discussed that. Analog is like any value from 0 to 5 volts or any value that is constant, and digital means either 0 or 1. our computer understands only digital things, like it understands only ones and zeros. So to convert an analog, and our sensors are completely analog, like temperature, it is 23 degrees, 24 degrees, 25 degrees, 23.75, anything like that. And our PC understands only ones and zeros. So we need to convert analog signal into digital. So for that we have an ADC, and that is there in our Arduino Uno. So ADC converts analog into digital. So as I said, we have got 10-bit ADC in Arduino Uno. So it can convert any analog signal into 1024, that is 1024 levels. Now if we increase the resolution, like if we have got say 16-bit ADC, then instead of 1024 levels, we'll have 65,000 plus levels. So that will be, so more the resolution, more the better. So the quantization error will be less, and the conversion process from analog to digital will be more better. So more resolution is better, but few things that we need to take care of is the memory that we have and we need.
Okay.
So that is also there. One thing.
All right. So we'll take up one more question.
Yep.
That instead of Arduino, can we use any other microcontroller in embedded system?
Yeah, we discussed this regarding previously also. We can use ARM7, we can use ARM9, we can use 8051 PIC controllers, we can use any of these controllers as well. But there is a problem with those, that is we need to write a program for them. And writing a program for ARM7, ARM9 is a very difficult task, because we need to know the block diagram of that and how it is there. A lot of electronics part comes in. You need to read a lot of books, you need to understand that, you need to see the coding, and the coding is very lengthy. So we can use that. If you are a pro, you can. But the thing is, it is a bit difficult. So when you start your journey in electronics, in the later stage you can use.
Okay.
But initially, I would suggest you use Arduino because it is very simple.
Okay. So there are a lot of options, but Arduino is the simplest one.
Yeah.
So can a physical device be connected to Arduino to record the data?
Yes, physical device can be connected. I think like physical device means we are talking about, I guess, sensors. So that means we are talking about a data logger. So we can connect a temperature sensor to it, and we can measure the temperature, and those temperature are to be stored in Arduino. We can definitely store it because Arduino has got 4K of memory. So in the, like I'm talking about Uno. So we have 4 KB of memory. So in that we can store that data, and the data that we'll be getting is of just 10 bits. So 10 bits, and we have got 4 kilobytes of memory. So we can store a lot of the data in it. So that is also not an issue.
Okay. So we have one more question from Mr. Pratik. Is Arduino also involved in the bigger manufacturing machine and robots in the industry?
Okay, so now the thing is, Arduino in bigger manufacturing industries or in embedded systems, what they do is they use, because they are making or manufacturing it for larger scale, so they stick to one controller, one processor. They choose one, they program for it, they make a PCB for it, and they use it. Now in that they are not using Arduino. Arduino is a prototyping board. So since it is a prototyping board, it has got pinouts, and those pinouts we can connect sensors, we can connect output devices, that is used for experimentation and learning of how these things are working properly. Now I doubt that they are being used in any of the bigger manufacturing industries on all, because they have got design engineers which are having more than 15-20 years of experience, and they can play with the controller, and they can play with the programming, they can understand that, they can even manufacture their own customized controller. They can go for ASIC, application specific integrated circuit, for that specific application, because they are going for mass scale manufacturing. So I doubt whether they will be using Arduino or not, but Arduino we are talking about, so that in the later run you can understand all these sensors very properly when you will play with it. And you cannot play with it by using 8051 and all, because the programming is tough. So use Arduino, very simple programming, and you will know all the input things, output things. You will understand how to design an embedded system, and you will learn that, and you will have a lot of capability, and then you can become an embedded system designer, and at that time you can go and use various these controllers and all these things.
Okay, thank you so much, sir. That's all for today, and if any other questions, we have one more question, we'll take that. What is the eligibility to learn Arduino? Do we need any prior programming knowledge for learning it?
No, the course that I have designed and which is available on millionlights.org website, that is designed in such a way that even a ninth standard student can do it. So more than 14 years of age also, he can also use it. He just needs to buy the kit, and along with those videos we can plug in the devices, write a program and do it. We have made it in such a simplified manner that we have also discussed about the software, from where we can download it, how to install it. In that detail we have gone. So anybody can take this course, anybody can write the programming and can build the embedded system. So we have taken that care. And if you are into electronics and telecommunication and computer engineering, then also we have made lot of things in it, so that advanced learners also will get lot of inputs from it, because the variety of topic that we have covered is plenty.
Okay, so it's very easy. So and we have a different level of courses for advanced and for beginners.
No. The same course is there, but initially we go with a slower approach, and later on, when they understand it, we are taking up with the sensors and all. Means the thing is, the syllabus is vast, but we are making it sure that even the 9th standard student can understand it.
Okay.
So since the syllabus is vast, even if electronic engineers come, we have taken a lot of contents which they have not learned already. So this is one course, but it is we have designed it in such a way that everybody will be benefited.
Okay. And can you please tell us about the career options in Arduino? That's a very interesting question.
Yeah, career, actually, see, if now smart cities in India is becoming, or even in the world you can say, smart cities, making cities smart, that is a hot topic now. To make cities smart, we need Internet of Things. Internet of Things means connecting every device to the net, so that every device will be sending data in the web, and that will be available in the cloud, so that anybody can access from any place. Like if you're going, you want to make your house a smart house, then what we'll do, you will connect sensors and all, and if you go out, then those sensors will be monitoring the condition of your home, and they will be sending the data on the cloud. So even if you are going out of town, we can, with the help of a mobile app, you can check the status of your home. Or say if I'm going to if I want to go in a city, so if I know the traffic condition before I leave, then that is good. So that is what is happening, traffic condition and parking situation and a lot of these things. These data are sent on the cloud, that is internet, and anybody from any place can access it. That is Internet of Things in a very small kind of thing. So if we are talking about smart city, it is inevitable without Internet of Things. And for Internet of Things, we require these boards and these things that will be. So Arduino has got a very important role in that. So with the help of Arduino, you can build these IoT kind of things, and you can also build a lot of robotics. This is also, we can use Arduino and make a lot of different robotic stuff, and you can build a lot of innovative things. So if you build an innovative thing, how to build it, that is the biggest problem. So Arduino gives wings to your imaginations. So whatever you can imagine of, you can build with the help of Arduino, and you can get a patent of it. If you get a patent, then that is your that is your thing, and you can sell it at a lot of cost.
And you can become a millionaire.
Yeah. So finally that's.
Yeah. So talking about career options, like due to technology, we have a lot of career options nowadays. And like we have a skills gateway program on our Millionlights channel as well, on Den and Next Gen. So the Den number we have 515, and the Next Gen channel number is 483. So if viewers want to advance in career, they can watch our program Skills Gateway, and it will be really helpful for them. So thank you so much, sir. And apart from that, if you have any questions after the session also, you can connect through our Facebook page, Millionlights. You can go to our website and ask the queries. And we have you can connect to us on Twitter, and that's Millionlights1. Instagram as well, or you can email us to support@millionlights.org, and or you can also give us a missed call on 022 307 78274. So thank you so much. And we'll be back again next week with another interesting topic.